The quadratic formula gives us a way to solve any quadratic equation. Even if the quadratic equation could be solved using a different method, such as factoring, or solving for x directly, or completing the square, we can always use the quadratic formula. It's just not always the quickest method. So here's how the quadratic formula works. It's an if-then statement. The first part is if we have a number times x squared plus a number times x plus a constant all set equal to 0, then I can solve for x by plugging a, b, and c into the following formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now some of the quadratic formula should look familiar to you. Negative b over 2a was how we found the x portion of our vertex when we were graphing a parabola in standard form. You should also recognize this plus or minus. This plus or minus is the piece that gives us two solutions. Now the other part of the quadratic formula, this b squared minus 4ac, is known as the discriminant. The discriminant tells us a lot about how our answer, our solution, is going to look. If our discriminant is positive, then we're going to take the square root of a positive number. And the square root of a positive number is going to give us a real number. So our solutions will be real. If our discriminant is negative, then we're going to take the square root of a negative number. And if we take the square root of a negative number, our solutions are going to be imaginary. We can dig a little further. If our discriminant is a perfect square, then we're going to take the square root of a perfect square. And the square root of a perfect square is an integer, which means when I'm done doing all this math, my answer will be a rational number. If I get a non-perfect square, then when I take the square root of a non-perfect square, my answer is going to be irrational. So no matter what math I do, I'm going to be stuck with irrational solutions. And the last thing that the discriminant could be would be 0. If my discriminant is 0, then I'm going to take the square root of 0. And the square root of 0 is 0. So if I simplify the top, I'm going to have negative b plus 0 and negative b minus 0. Well, adding and subtracting 0 doesn't affect this b, so I end up with just negative b over 2a. I end up with one solution. But that one solution is what's known as a repeated solution. I still get two solutions, it's just the same solution twice. Let's look at a quadratic equation and solve it using the quadratic formula. Step 1 is to set the quadratic equation equal to 0 by subtracting 8x from both sides of the equals. 6x squared. Now I'm going to write my x term, then my constant. Notice that my powers of x go 2, 1, none. Now I'm going to identify a and b and c. And once I've identified a, b, and c, in order to solve for x, I'm going to plug those numbers into the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Notice that every time I plugged in a number, I use parentheses, and I haven't done any math yet. I've just plugged the numbers into the formula. Now in my next step, that's when I'm going to actually do some math. A negative negative 8 is positive 8, plus or minus the square root of negative 8 squared is going to be positive 64. This number squared should always be positive. Whether it's a negative number or a positive number, any number squared, unless it's imaginary, is positive. Now here I have 4 times 6 times 3. 4 times 6 times 3 is 72. Now I just need to figure out if I should add or subtract 72. To figure that out, I'm going to count my minus signs. I just have one minus sign. If I have 1 or 3 minus signs, either an odd, 1 or 3, an odd number of minus signs, I'm going to keep this minus sign. If I count an even number of minus signs, if I have 2 minus signs, this is going to be a plus. All over 2 times 6 is 12. Now I'm going to simplify what's underneath the square root symbol. 64 minus 72 is negative 8. At this point, I can look at this negative 8 and figure out what kind of solutions I'm going to have. Negative 8 is negative, so my solutions will be imaginary. And 8 is a non-perfect square. If I take the square root of 8, I do not get an integer. So my solutions will be irrational, imaginary solutions. In order to find those irrational, imaginary solutions, I need to simplify the square root of negative 8. I need to rewrite the square root of negative 8 in simplified radical form. To do that, I'm going to rewrite negative 8 as 4 times 2 times negative 1. So I'm going to have 8 plus or minus 2 square roots of 2 I all over 12. Now I need to distribute this division. I really have 8 divided by 12 plus or minus 2 square roots of 2i divided by 12. So I'm going to distribute this division over addition and subtraction. If you remember, this division bar is a grouping symbol. X equals 8 divided by 12 plus 2 square roots of 2i over 12, or 8 divided by 12 minus 2 square roots of 2i over 12. 8 divided by 12 is 2/3 plus, the only things I can simplify here are this 2 and this 12. 2 divided by 12 is 1/6, and 1 times this is just the square root of 2i over 6. Or 8 divided by 12 is 2/3 minus 2 divided by 12 is 1/6 the square root of 2i divided by 6. Now at this point, 2/3 is a rational number, but the square root of 2i is an irrational imaginary number. I cannot combine these two numbers. If I would have a fraction plus or minus a rational fraction, I would have to add or subtract those fractions. In this case, because I have an irrational number, I can't add these two fractions together. They're unlike terms. So this is my final answer.